Class, and welcome to lesson 3.6, applying Pascal's triangle. So yeah, last lesson you worked on developing a Pascal's triangle, which was kind of different. It's organized counting, it has patterns, but now we're going to relate it today into how it fits into this unit. So that's why we're going to apply it to some real life situation. For today's examples, folks, I'm getting them in your textbook. Let's see if there we go, it's going to cooperate with me. From page 254. So it says read through the bucket example. So we're just trying to figure out how many different pathways can this water flow. Well, if you take a look at each bucket may have a certain pathway as it gets to it. So the first bucket on top right here, there's only one way the water can come from, and it's from up above. Okay? When I get to the second bucket right here, again, I only have one way that water can come from up above. So I've got one way here, and with this other bucket that I just highlighted, it's also going to have one way. But when I get to the next line, you're going to see there's a variation in this. Okay? This has one way, but notice this bucket here that I just dotted in red. Notice there's two possible ways the water can come from. 1, 2. So there's two possible ways that water can come from. Okay, whereas the next one only has one. Okay, let's look at the last line. The outside bucket only has one way, but be careful here. I have one pathway here, but two possible from there, so 1 plus 2 gives you 3 different ways there. Okay, likewise with this next one. You could have 2 possible ways coming from this one and 1 this way. So I'll show you the different ways, for example, for this one. If I grab a highlighter, I'll show you the different pathways for a highlighter. Okay, so the first possible pathway could be this way, this bucket to here. There's one. Okay? My second could be, I could go this way to there. There's 2. And my third pathway could be coming all the way and in. So 3 possible ways to get to that bucket. Okay? And then if we asked for the total number of ways, you could add them all up for the bucket flow. All right, next one is again on that same page, 254. It's talking about a traffic issue and taking a look at a grid system and how many different ways does it take you to get from A to B. Now, if you live in a urban city, unlike where we are in Clinton, Ontario, there are several traffic lights. Imagine having a traffic light at each one of these intersections. It's a little bit crazy, okay? But what we're going to do is we're going to find out the number of ways to get from A to B, okay? So we're going to break it down into each intersection and see what happens. So at this intersection, I could only come from one way, okay? I will mention that it only says you can go left to right. So left to right, and you can only go up to down. You can't go back up and around, so you can't loop. Okay? So we're always working from the direction of A to the direction of B. And that's what denoted by these arrows. So you can only go down or across. So as I go across at each intersection, hey, that's still one, that's still one, still one, still one, still one pathway. Okay, same as I go down. If I go at this intersection, I've got 1, this intersection 1, this intersection 1, this intersection 1. But when I get, oh sorry, one more here. Okay, but when I get into the middle, it's going to be a little different. So if I take a look here, folks, I could come from this direction or this direction, so that's a two-way street I could have come from, right? 2 different ways to get there. What does that mean, folks? I could have come over and down, or I could have come down and over. That's just showing you there's 2 different pathways. All right, so let's take a look here. Here, ladies and gentlemen, I could have had 1 possible from up and 2 possible from there, so that gives you 3. At the same time I'm going to do this, it's going to be 3. So hopefully you notice this pattern right now is you're adding just like you did on the Pascal's triangle. Just turn the Pascal triangle on a diagonal. So take your Pascal and look at it on a diagonal, okay? So you'll see the numbers 1, 3, 3, 1, okay? If we take a look at the next one here, ladies and gentlemen, I got 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6, okay? I'll do the same thing across because it'll make the same result because it's symmetrical. So I'm going to go 4, 5, 6. I have an extra one here to make it 7. Okay, now I want to meet in the middle here at Agnes Road and Descartes. It's got 3 from one direction, 3 from the other, so that's 6. Okay, and I'm going to go 6, 10, 15, and 21. Do the same over here. 6, 10, 15, 21, and 28. Everybody okay with that? All right, keep moving on. Next intersection here in the green is going to be 20. I'm going to go down first. So it'll be 35 when you add them and 56. Okay, do the same across. So it will be 35, 56, and add another 28, which is going to be 84. We're getting there, folks. Okay, next intersection in the middle. 35 plus 35 is 70. 70 and 126. Sorry, 70 and 56 is 126, which becomes 126 there. 126 plus 84 is 210. Almost there, folks. Down here we have 252. So you take 252, folks, and add 210, and you should get an answer of 462. So cool. So we say, therefore, there are 462 ways to get from A to B. Okay. All right. You say, okay, that's great, Miss R. We see the pattern, but how could we have just used our Pascal's diagram right away? All right. So I want to figure out what's the shortest path you could have taken to get from A to B. Okay, so we could try the diagonal. Doesn't really matter. Let me try a highlighter again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's see if there's any less if I go on the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it doesn't matter. The shortest path is going to be 11 spots. Okay, so shortest path equals 11 spots. Okay, and how do we do that? We have to go 6 east and 5 south, or a combination of the opposite. Okay, now take a look at that with Pascal's triangle. So to relate to Pascal's triangle, please take it out. Okay, I want you to look at, if we want to find the number where it's on the 11th row, 6th number. Okay, that's 462. So it's there right away. The other way you could have looked at it, hey, if I did 5 south instead, okay, that would have been also another case. So that would be 11 and 5, which would also be 462. Okay, so just showing you that you can tie Pascal's triangle in, and guess what? You can use your Pascal's triangle for your test as long as you leave the backside blank. Awesome. Okay, next one. How many different ways, pathways are to spell the word reports? Okay, and I'll tell you, you'll have a test question like this and probably a review question. So how do you set this up? Okay, so you figure out your pathways. The difference here, folks, is Pascal's triangle goes nice out and square. However, when it goes back in and out, the numbers get a little bit skewed. Okay, but you're always going to start at the top. Okay, so we're going to start here. Sorry, guys. Winter cough. Okay, so we start here. So we start here, and then how many ways to get to the E? There's one on each E. Okay, the outside P's, there's only one way to get there, but how many possible pathways can I get to the inside P? There's 2, one from the first E and one from the second E. Okay, going to the O's, hopefully you realize there's 3 for each of them. Okay, so now to get to the outside R, there's only 3 for each outside R, but on the inside, 3 plus 3 is 6. Everybody good with that? Now to get to the T's, I'm just changing color so you can see it a bit better. So we've got 3 for the outside T. The inside T's get 9 because you're adding both pathways consecutively going up. And the outside t is 3. Now to finish off, what our s is going to look like. So we're going to have 12 for this one, 18 for this one, and 12 for this one. So the total number of ways that you could write it in this arrangement is 12 plus 18 plus 12, which equals 42 ways. All right. Okay, next, if you guys played chess or checkers, here's a cool thing to realize. Okay, determine the number of paths from the bottom of the board to the top of the board. And we're going to use the spot where we are. Okay, so remember about checkers, if you don't know, folks, you have to travel in a diagonal. Okay, you can't, for example, in this case, we're only on the white checkerboards, we're not on the black. Okay, and the rule of chess until you get crowned is you can only move upward or away from your side. Okay, all right, and so don't forget it's diagonal only. Okay, so as I move up, there's only one way to get to either diagonal. Now notice here, I can't get here, I can't get anywhere over here. So these are going to be left blank because I can't go backwards, right? Okay, so how many ways do I have to get in this? How many different pathways gives me to that dotted spot? There's 2 for that one, 1 for this one. Okay, to get over here, I've got 2 pathways for this one. Here I have 3 guys and 1. Okay, actually 1's going to be all the way along there. That might help you. Okay, and then counting, you've got 5 here, 3 here. Just keep counting up. 4, 8, and 5. 5 and 8. I apologize. That should be 4 here. 3 and 1 is 4. Sorry, guys. Okay, and then 4 and 1 is 5. Now we're good. Okay, so 5 and 8 is 14. Sorry, that makes 9 because of the 4. Sorry. Oh, boy. I wish I had auto erase on this, guys. Okay, let's back that up. 5 plus 4 is 9. Okay, now 5 and 9 are 14. Okay, we only have 6 ways here. Okay, and last one. It's 14 ways to get to that one, 28 to get to that one, 20 for the end here, and 7 possible ways to get there. So, total number of ways. So number of ways equals 14 plus 28 plus 20 plus 7, and that equals 69 different ways. All right. Okay, last one. We're going to throw a little tricky spot in it here. Okay, so again, we're on the white, and the X means you can't go in that position because maybe one of your men is in there, so you can't move on that spot. So that X you have to be careful of. Okay, again, we can only go on diagonal and only go upwards, so all of these spots are going to be left blank. Okay, so as we remember our diagonals as we go up, it's a 1 for Pascal's triangle. Okay, and now look at our interior positions. Okay, hopefully you can recognize that. So we're good here. Where we get stuck is on this spot. We can't get to this. So for example, this one, ladies and gentlemen, I have a 3 and a 1. Okay, now when I go to try to do this this rectangle out, I can't get anywhere from here, so I can only get 3 from that way. Okay, likewise for this one here. I can't get any from that way, so I have to go there from the other direction, which is just 4 moves. Okay, 4 plus 4 is 8. 3 plus 7. Sorry, 3 plus 4 is 7. We've got 4 and 7. So, number of ways is going to equal 5 plus 9. Or did I make an error? Oh, sorry. Hold on. 4 plus... I made an error here. Sorry, my apologies. 1 plus 3 is 4. 4 plus 1 is 5, which gives you 9 there. Okay? And that affects this. That'll be 4. And that'll be an 8. I apologize, guys. Hopefully you can erase that too, which gives that a 5. Okay? So you got 5 plus 9 plus 8 plus 8. So that equals a total of 30 ways. Okay. So, ladies and gentlemen, you have lots of examples in the textbook that are all visual like this. Please do not write in your textbook. I will give you a plastic sheet and let you borrow an overhead marker so that you can just overlay it over top of the question so you don't have to draw the whole thing. Okay, so please do not write in your textbook like these examples. I'll give you a plastic sheet. All right, here's your homework for that. Page 256, numbers 1, 2, 4AC, 6, 7A, and 9. And I believe from past years, 7A has the wrong answer in the back of the book. It should be 33. So please make a note of that. Sometimes textbooks have wrong answers, but that one should be 33 instead of whatever it is in the book. Okay, folks, have a great day. Come see me. Hopefully you enjoy this cool Pascal triangle and how it relates to permutations. We're still tying it in. And see me if you need any help. Have a great day.